All right. Hey, everybody. Welcome. It is Friday, February the 3rd, 2023. And Fabrizio and I are getting together to talk about the Cluster API Kubemark provider and a testing PR that he's put up that's kind of adding end-to-end testing. So I'm trying to understand it a little better. We're going to dive into some of the details. So yeah, my first question to Fabrizio, though, is kind of about the topology of how these tests are set up. Like I can see in the test that we're like, one of the big things is to create a workload cluster. And in my mind, that makes me think that we already have a management cluster running. And so then we're creating a workload cluster, and this will be important to setting up like the cluster autoscaler and everything. So yeah, so I'm kind of curious if you could talk about the topology a little bit.
Yeah, sure. So let me share. So we'll take a look at the code. Okay. So let's start from.
I think you might need to increase font size a little bit.
Yes, let me find out how I can do this. So it's just Control Plus. No, edit. Oh, let me switch to Visual Studio Code, and then eventually, if we need, we go back to Visual Studio Code. Is nice for that.
Yeah, cool. What was the other tool?
Golang.
Oh, nice. Okay.
I prefer Golang for debugging, refactoring, stuff like that. But I use both, so I'm kind of bipolar. Okay, so everything is below test end to end. There is a separate go mode, so this prevents basically all the test dependencies like kind or whatever we use inside test to leak into the binary. And then it is a Ginkgo suite. So everything starts as basically Ginkgo suite. You have a unique test where you register an ender and you run all the specs. And
right, don't forget to increase the font size too.
Oh, sorry.
No worries. my eyes just aren't that good anymore.
Yeah. So, okay, test end-to-end test. There is only what is a recognized end-to-end test, and it basically runs specs. And specs are everything. Just to look at one, it has everything below described, basically. And going back a little bit, so when you run Ginkgo, there is this these things that are called the before suite and the after suite. So this before suite and after suite is a piece of code that runs basically before any your single test. And we use this default suite in order to do a couple of stuff. So what we do, the first thing relevant that we do is that we load end-to-end config. End-to-end config is a file that is defined here. And it is kind of it drives all the tests. So in this config, what we have, so since we are using kind, we have the first thing is a couple of images that we can preload into kind, so things will be faster. So you don't have to wait for download, basically. And this preload, it tries, so if you have it is a try, except for the controller one that you have to build locally before running the test. Everything else is optional. So if you have it locally, it will preload in kind and things will be faster. Otherwise, when your test starts, it downloads. Then the second part that we have is probably the most important, because it allows you to define which provider you are going to install in the management cluster. And so in this case, we are telling, for instance, as a core, we want cluster API. Sorry, we want cluster API. In this case, we want cluster API from this version, and we are basically downloading it from a release. We are not building, because we're testing Kubemark. We need also a metadata file for the copy, and we have it somewhere here.
Now that, just for reference, that's a metadata file that's coming out of the testing directory. It's not the metadata from the root of the Kubemark repo, right?
No, it comes out from the testing directory.
Okay.
So, and we use it. All this file basically. So we are setting up the cluster API, Kubernetes booster provider, Kubernetes control plane provider, Docker, because in some tests we use kupd, and Kubemark as well. Okay, the big difference here is that for Kubemark, we are not using a release in this case, but basically we are building the Kubemark component from this folder, so from the source, like you do when you release. And then you have also the chance to add some file for your Kubemark provider. In the same way as you add your metadata, you can add some cluster template. Last but not least, you can set some variable that we are going to be used in the test. But what is the result of this config file? If we go back to the test suite, it loads, and then it does this stuff, which is create cluster API local repository, which basically goes into a folder, which is the article folder and a repository. And this is the output. If you go here in the artifact folder, what you can see is that you got all the provider that your test is using, like cluster cattle expected. Does this make sense?
Yeah, it totally makes sense.
Okay, so basically, with all this stuff, which is provider with their own YAML, metadata, provider with some other files like cluster template, we can basically point, when we initialize, when we work with our cluster, we can point cluster cattle to this folder and this cluster cattle config file. And that means that your test is going to happen in isolation. So it does not depend by internet or by external variable. We create this repository instead of relying on things that is published on internet or in GitHub release, etc., because we want our test to be repeatable. That's the main point. So far, so good, Mike.
Yeah, this is awesome. This is kind of exactly what I was wondering. I wasn't quite able to put it looked to me like we were doing kind of the quick start, kind of use kind to start a management cluster and everything, but I wasn't able to piece together where all the artifacts were coming in. So yeah, this is excellent.
And then we will try and debug it. And so yeah, I can show also how you can debug it, which is another interesting thing. So if we go back here in this in what happened before any test start, so we read the end-to-end config, we create the local repository, which is that folder where that cluster cattle will use later on, and then we do two stuff. Set up the booster cluster. So that booster cluster, it is a function that can work in two ways. If you are not telling use an existing cluster, basically it is going to create a kind cluster for you. Otherwise, it will just use the one that is in the current kubeconfig. And why we use these? Why there is this OMP option? Because if I want to repeat my tests many times, it makes sense to create a kind cluster before, and then run tests with use kind cluster. So every time initialized is already there, it doesn't have to reapply all cluster cut. It figure it out that everything is already installed, and it just move on to the test.
So just to get this straight, like if I wanted to, I could start like a kind cluster on my testing machine and get the kube config from it, and then build the test binary. And when I run the test binary, it can find the local kube config and then use that instead of creating a new. Okay, that's cool.
Yep, but there are a couple of way to run tests. I will show them because it is the fun part and the biggest difference. Because basically, here we can debug everything. There are ways to debug everything. Instead, if you go with script, you cannot attach any debugger to it or this kind of part.
Yeah, totally. No, I think it's super valuable to be able to understand how to how to be able to run like the controllers with a debugger attached to them locally, because then you could just debug anything, right?
Yes, exactly. And so just to finish what happens in those before suite stuff, the second, where it is, okay, here it is. After setting up the booster cluster, the final step before starting test is to initialize the booster cluster. That means that it is running cluster cattle init against this repository. And also in the case, it is a little smarter if it before calling cluster cattle init, it does some nesting here. Oh, why it does not? I don't know why it drives me to the implementation of the function, but inside this function, it checks if provider are already installed, it just skips the operation. Otherwise, it install provider, and it also basically starts streaming logs of the provider. So after your test, and here I have a couple of tests. After your test, if you go and you look, I don't know. I have to find one test that worked, but during the test, it basically save a bunch of stuff under this folder, including logs also from the provider itself. Why are we doing this? Because, and let me show how it looks when you run this in CI. Because let me say, when you are running tests locally, there are ways to look at logs. But if you run tests in CI, basically your test machine gets destroyed before you don't even have access to it.
Right.
So
right.
Your test has to produce everything. So if you look at there should be pool, the cluster side, proper copy release. So let's start by
And this is the standard Kubernetes test grid site that you're on, right?
Exactly. That we are using for copy. And behind we are calling exactly the same code that we were looking, but implemented in Cluster API. And so if we look at, let's look at full release. I was searching for one. Sorry, I don't want this why and I don't have it, because I'm in Cluster API 1, 2, 3, because I'm in the test for one of the branch. I have to look Cluster API provider, where it is. Cluster API, okay. This is the main branch. I was looking not at the main branch, but to an old branch. So, for instance, this one should be a good one. Okay, if you look at and here and you go looking at one test, then you go to look at artifacts. Below artifacts, when you run this in CI, you will find the repository folder that we just saw before. So you in theory you can download it and copy locally, but also for each cluster you will see all the namespace and stuff that it created. It will capture for you all the YAML objects. It will capture for you logs. So after your test is failed in CI, you can triage it. So let me say, one of the biggest advantages of using the CAPI end-to-end test is basically that while your tests run, we have already all the machinery to capture everything that can help you to triage a failure that happened on a test environment that has already been destroyed, which is how Prow behaves.
Yeah,
Yes.
And now just one question about those artifacts, because we use a similar system in OpenShift. We have a tool that we call must gather that like pulls all the information out of a cluster and creates these similar kind of artifacts. But like if I'm running a test and my test creates machine deployments and those machine deployments create machines, and then the machines all go away by the end of the test, I won't have manifests for those machines and machine deployments that were created during the test, right?
For the intermediate, usually for the intermediate test, no, but it is possible. Let me show.
Right.
So,
This is like important for people who might be implementing tests, is that if you need to save those artifacts, you'll have to specifically save them or something.
yes, exactly. So if I think that we are done, let me say, from what it is the before suite. So create the repository folder, set up kind if necessary, init if kind, and then we are basically finished. All this code is more or less copy paste from Cluster API. Let's look at one test. So given that at how Ginkgo behaves, it means that it first ran this before suite, and then it starts running all the tests. So all the tests. Test have, you can run before each, which is your preparation, how you prepare your test. Usually here what we have is very simple. We check because we kind of define a set of input variable for our test. Here we validate the input variable and we just set up a namespace for where the test to run. Because in order to avoid each test to conflict with each other, each namespace run on its own test. And then if you look at the test could be, usually is pretty simple. It is, in this case, it is apply cluster template and wait. So what we have is that in the Cluster API test framework, we have a bunch of utility functions like this one that you can reuse. This one is a pretty big one. It create a cluster, apply CNI, wait for the control plane to come up, wait for the workers to come up, etc., etc. So it basically create my cluster and check that everything works. Yeah, and those functions are already there, most of them, but we can even add more. And they are pretty fixable. So what I simply did, I called this function passing, okay, here it is where I want to generate logs to write everything related to this test. Here it is the cluster cattle config that I'm going to use, that at the end it is this cluster cattle config that I just generated. And let me say, all the test machinery gives this to me. Yeah, here it is the kubeconfig part of the cluster where I want to create the management cluster where I want to do this operation. And again, the machinery test gives me this bootstrap cluster, which is the kind one. The infrastructure provider I want to use, the flavor that I want to use, and so on and so forth. So all the parameters for the test to pass. And here it is what we were just talking about. At the end of the test, I dump everything into my backup folder. And this dump everything it is a function. So it is intentionally by me that write the test to only bump everything at the end. I can do it in any intermediate state. And
Yeah,
this function,
this is important to remember, though, right? Like, if you're writing a new test suite, don't forget to do this part at the end.
yeah, but just to, I think that this gives the sense. So here it is the meat of your test. You can do whatever you want. And now I will show what I'm doing for the autoscaler test, because now I'm doing this one is a simple test. Create a machine. It uses a template. If we go and look, we use, in this case, we use the default template. The default template means you can go here and see it comes from Kubemark. It is cluster template because it doesn't have any suffix, and it is a cluster that just has a Docker cluster, KCP using Docker machines.
But this is a great test, though, because it validates our example, or like our basic example scripts or whatever. So like if these don't work, we're definitely having a problem.
Exactly. And then it has a machine deployment with some Kubemark machine.
And just to go back to the function that you were running to create the entire cluster in the actual test, that you were talking about that apply cluster template and wait. I'm assuming that there are like Ginkgo and Go Mega assertions that are happening inside of that function. So if it doesn't reach what it's trying to, it'll create like a Ginkgo error or something like that.
Yes, exactly. So, and by the way, I'm jumping in copy. In copy under test, there is test framework. Here there are tons of that function, and that one is here. Test cattle. You can find also the one that we were seeing before, like create a repository. All the goodness. And here we were looking, but let me grab this way, because if I look, for instance, at where it is, quick start. Okay, the copy quick start test. At the end, it is really the same things. Apply cluster template and wait, and that's it. And if we go and look, oh my gosh, why it doesn't go to the definition? Go to definition. I don't know why it's not resolved with definition. Let's try a different way. So go now we need to go long, no matter.
Right, totally. There's always something weird going on with the tools behind the scenes, right?
Yeah. What I have to do to move these to this. Okay. Yeah, now you can see Golang. Let's see if I can increase the font. I remember it was not difficult, but I don't remember the code.
Right, it's just difficult enough to fall off the stack, right?
Yeah, I use both, but I'm really bad at both. So
Well, I mean, you're doing better than me. I use Vim for everything, so.
No, I'm trying to learn what increase font. Yeah. Because there is this reset font size, but I don't want to reset. I want to increase it.
Yeah, it's weird. Like it seems like this functionality should not be that difficult to find, right?
Yeah, let's do this way. Help from home. Stefan.
Nice.
Yeah.
That's awesome.
We'll ping him later. Okay. Yeah. Let's try to. I can decrease the screen font. That's one is a nice one. Setting. Where it is. Appearance. Oh, come on. They changed the entire control plane of this.
Did you get a new version of the OS recently?
Yes. No, this is the dock. Display. Okay. This one. Let's see if. Yeah, it seems better.
It's better.
Okay,
yeah.
So we were in cluster API. We were trying to look at the definition of that function. So test and to end. We were looking at quick start. And yeah, this is, as you see, it has a lot of expect. And then you read the cluster template, you expect the cluster template to not be empty. You apply it. It has some hook to run in. Then you discover the generated cluster object. I don't know, it waits for the control plane to be initialized. It applies the CNI. It does a bunch of stuff. It discovers and wait for the machine deployment, for the machine pod if they exist. So this is a function that is used almost in every test by CAPI and by a bunch of providers. So,
and this is kind of a mental note for me as well, is that as I'm getting more into these tests and kind of understanding them more, it sounds like checking out the framework folder is a really good idea, because I wouldn't want to try to start like re-implementing some utility function that we've already created or whatever. So it seems like I'll have some time to study that.
Yeah, there is really a lot here. And as an example of test, but also as in the framework, there is really a lot. And so, yeah, look at an existing test or reach out and ask. But let's go back to Kubemark and we focus on our running test, how we can run tests. So, okay, the simplest way to run tests, let me say, I can run them with a make type, with a make target. There is a make target. It does everything in build, ginkgo, and then start. It takes in a couple of variables, so it allows you, I don't know, to focus on one test instead of one other. If you want to run only where it is.
Right, like you can pass in the ginkgo regex or whatever to have it parse the test. Yeah, that
exactly. If you want to run only the quick start, you have to pass something like quick start or PR blocking. And if you want to run the autoscaler, you have to pass something like where it is the beginning of the test. This one is makes sense to take a look at. It's a little bit more complicated. Autoscaler,
right.
And then everything works. But of course, if you run from the make file, basically you cannot. Yeah, it is the same that happened in CI. this folder gets created. Eventually, you can Docker do Docker exec, go into, but you don't have really control. Typically, tests with Docker or Kubemark are fast, and so are kind of hard to debug. And so there are a couple of ways to run this test. The one that I prefer, so in theory, you can even go here and debug here, and just passing some env variable to the debug. The way that I prefer instead is to use a tilt cluster. So let me get a tilt cluster. I use I create from Cluster API. So I use the utility that we have in Cluster API. So let's switch a little bit in Cluster API just to show this. So okay, in Cluster API there are a bunch of utility for tilt. Let me say the most important thing is that you have this tilt set. You need to have this tilt setting in your copy repo. And one thing that I can do is, okay, I can basically set up the list of provider that I want to get into my tilt file. And yeah, I have already configured Kubemark, and I just enable it. And there are a bunch of other things that you can do. For instance, if you scroll down, I have enabled debugging for the Kubemark controllers. So I can even debug controllers when they run. But let's get there one step at a time. So here I have my tilt file with whatever I need. What I can do is that make tilt up.
And if you're, because I've had problems running tilt in the past, but if you're doing this type of debugging where you want to attach the step debugger, you really want to use tilt to manage the cluster API objects and whatnot. Is that the idea here?
Yeah, because why we are using tilt? Because what we are doing with tilt is, yeah, first of all, tilt gives a nice workflow, because you can, once it manages your deployment, you can change the code, reload without recreating everything, and it redeploys an image. We can even do this. The other things that tilt gives you is that, yeah, we have a bunch of stuff in tilt. I make an example. So let's start by the easiest one. For instance, for debugging, what we have is that when tilt deploys stuff and your deployment, it basically exposes a port. If we go back, Kubemark is 3000 and 0012. And if I go and look at Kubemark, it exposes a port. So using this port, it makes me easier for me to attach a debugger. Then I can go here and basically build a debug configuration like this one. I simply tell, oh, these things run in localhost at, where it is, Kubemark. It runs in localhost at 3012. And I got a debugger that can debug Kubemark. If instead I have to do this without tilt, it will be a little bit more difficult, because the the Kubemark provider runs inside a kind, and so I don't have this proxy capability that Tilt gives me. I don't know if this is clear.
Yeah, like what is the port it's exposing? It's exposing like a port that you can attach the debugger to?
Yes.
Okay.
Basically,
Could you use Delve or any debugger, or does it have to be the Golang debugger?
no, Golang debugger is there. So
Oh, okay, cool. You
you
can
can use
tell
whatever.
I'm not deep on the step debuggers.
Yeah, it works from Visual Studio Code, but it is Delve at the end. And this is one stuff that we do. So it helps us to proxy into providers. Then we have also some other stuff. I don't know. There is a way, so we can basically link a folder where there are templates. And if I go back and look at Kubemark, if I find it, so here I have my setting for Kubemark. No, sorry, it is not here. It is in copy. Okay, for instance, I'm telling that in my local temp folder under Kubemark, I have some test template that I can use when debugging copy. Because I can use this to debug no matter of I'm running end-to-end test or not. So if I go there and I click here, it is going to deploy a cluster, and then I can delete it. So I don't have even to do kubectl apply and whatever. And other things, and we have a lot more because just to show you, we have observability. I can quickly enable Grafana, Promtail, Locky, Prometheus, the Cluster API visualizer. Just on commenting this line, they got installed and I can use it. And all of them worked thanks to the Tilt capability to proxy stuff. So yeah, it is a lot. And reinvent this will be a lot of work.
Yeah, totally. I think the networking is probably the problem I ran into when I was trying to run Tilt on Fedora, and like it didn't work well for me. I could get it working on Ubuntu, but yeah, like the networking just didn't work for me.
I even use it from Ubuntu build box in remote, and basically I expose the Tilt port and then I debug from locally. So on the Ubuntu it works well. On Fedora, I'm not using it frequently, even if I'm planning.
I have a feeling SE Linux probably got in the middle of what I was doing and was denying some network connection or something. But kind of, for the benefit of those who might be watching this outside of just you and I here, Tilt is not specifically a cluster API tool, though, is it? It's like a generic Kubernetes tool that you can use with lots of different things, right?
Yeah. Tilt is a nice project. It is basically it allows you to develop. You apply a YAML to a cluster. It basically take under management whatever image are behind this stuff, and it gives you a nice user experience. I make you an example. So if, for instance, now this might Tilt. Okay, as you see, there is nice this UX, and we have a pretty complicated setup in copy, but that's not important. As you see, I have my controller running. Okay, and I can see logs from all of them, and this is already nice. While I run tests, I can go here and look at logs. But another thing that I can do, which is super nice. Let's assume that I go in Kubernetes Booster Provider, and I make some changes. yada, yada, yada. I save some changes. It recognizes, you see, that something is changed. And I can simply trigger rebuild of the copy binary and the redeploy of the booster provider. And I get a new version in few seconds without rebuilding, redeploying, etc., etc.
Yeah, I mean, this part's super powerful, right? Yeah, because all the different namespaces and controllers and stuff the Cluster API has, like, makes it really simple.
Yeah, it takes a little bit of time. It is well documented in the copy, by the way. In the copy book, we have this page. Tilt, rapid iterative deployment with tilt that explain everything to you. Yeah, it takes a little bit time to get it right, but you can ask but once you get it, your development workflow will be super fast. And
yeah,
it works also when we are doing end-to-end test. So let's get back to end-to-end test. So we are tilt running now for copy. Okay, now let's get back Kubemark. Okay. Now what I can do is that instead of running tests with make, I run them with a configuration, and it is documented in the page how to build this configuration, both in Visual Studio Code or in Golang. It is documented in the copy book, and basically I'm running the end-to-end test from the command line, and what I'm telling is that, okay, I'm passing a bunch of parameters, all of them documented. So I'm telling, oh, this is where you have to store the artifact folders, where you pick your config file, Ginkgo focus because I want to run only one test. And then, a bunch of, for instance, I'm telling, oh, hey, use my kind cluster because so if I can in parallel both debug the end-to-end test and the controllers. And then it is really it. Let's assume, okay, this is the end-to-end test that I want to run. I just go here and place a debug. Let's clean up this one so we can follow it. Delete it. We want to, let's assume that we want also to understand how it works, the setup of the management cluster. And that's it, debug.
Yeah, that's really cool. And on when you were showing the run configuration screen before, those parameters that you had in the window, those are the parameters that get passed to the end-to-end test binary that's created from the process. Okay, cool.
Yes, exactly. And behind the scene, it uses Delve. So you get here, you get a debugger with whatever you need, but this one is reading the end config. I just okay. Okay, now if usually take a little bit for load, and so okay, you see, it just recreated an empty directory. This is what we were discussing. And if I go, this one will be an op because I'm passing using existing cluster true. Where it is using existing cluster, it should be true.
Yeah.
So this one, it is an op. This one is again an op because it will check if in my booster cluster provider are already running, and provider are already running because they are managed by Tilt.
Does it check the versions too? Like if I said I want 1.3.1, okay.
No, it is a lazy check because we implemented so if they are already there, you set up as you want, and given that you are doing development, a version is often not reliable.
Right, totally.
Okay, so yeah, at the end, the setup part, the before suite part done, and now we are debugging. We are inside debugging the autoscaler test. The autoscaler test is kind of different from the other one. You see, it is a little bit. It has something more. So we created because we want to do more. What we are doing here is that we create a workload cluster. In this case, it is the same as before. We just create a workload cluster. So let's give it time, and if we want, we can. Eventually I can debug and do whatever, but I can also, I don't know, follow here by doing Docker PS. So as you see, it is creating the load balancer for the workload cluster, the control plane. We can.
Can you see this activity in Tilt as well, or is Tilt not connected to this yet?
No, Tilt, where it is? Where it is my Tilt? Not this one. Okay, here it is. Tilt. In Tilt, you can see the activity of the controllers. So if they are processing, capd just created stuff, and so we can follow what is happening. We set up the provider ID, etc. We can look. capb probably is waiting for the cluster infrastructure to become ready.
Yeah, being able to switch back and forth between all these logs is probably the most useful thing. You learn a lot about Cluster API just looking at all the logs.
Yeah, exactly. So and then why? And where I am. So yes.
So now that I understand the topology of how we're setting up the test, though, I think like my comments about the kube configs for the cluster autoscaler, that's probably the problem that we're running into here.
Yes, definitely. So because why is it taking so long usually? There is something. Yeah, the only things that it happens, but it is probably Mac networking and Docker networking not playing, is that sometime controller gets stuck into communication problem. I just usually restart them. I don't know, sometimes it happens frequently, sometimes just no. And this basically blocks the debugging of the sequence. But
networking is enigmatic sometimes, right?
Docker networking is just on Mac is just not good. But that's the gist of it. So you can write everything basically as a good code. For instance, in this bit of code, I'm trying to install the autoscaler. This does not exist in Capi yet, so I'm writing it now. In future, we will move it in Capi. But my idea was that, okay, we read an autoscaler YAML that we provide, and we are, again, it comes from data. I have a YAML here. And in my Kubemark config, I'm telling, please move the autoscaler somewhere where the test can use it. But yeah, I can read it. What else I'm doing? I'm applying it, and then basically I know what is called the autoscaler, or I can parse the file and find out the autoscaler name. I'm trying to wait for the autoscaler to become available. And then I set up to watch the autoscaler logs using, you see, I'm reusing utilities that comes from the framework.
Right.
Just
Yeah. No, go ahead.
Just reassembling them together in a slightly different way.
Right. And this is what I'm saying. Studying the framework is going to be kind of vital to my knowledge here.
Just ask and look at existing tests, try to copy them and start from there. So
yeah, totally.
Yeah, but yeah, there is really a bunch of functions. And but let me say, this is what you have in your script, with the difference that, okay, it is written in Go, and you can also add stuff like, oh, now wait for things to check that everything works well. And yeah, the next step is that I'm adding a deployment, which basically runs busybox sleep, but allocates some memory. And after this, I wait for the deployment, to get ready. And here I got stuck because basically machine were not scaling up. But that's really it.
Right. Yeah, I think like for the most part, the test looks sane to me. Like it looked like it should work the way you want it to. We just need to get the autoscaler configured properly, and then it should do exactly what you're talking about. Because like the workload looked good to me, the way it's scaled out, it should do exactly what you want it to. It's just a matter of getting the cluster autoscaler so that it can look at the pods and the nodes in the workload cluster, and then it can look at the machine sets and the machine deployments and the machines in the management cluster. But like I think the service account is already set up for it to run in the management cluster. So that side, we just need to tell the cluster autoscaler to use the service account, and that the service account is authoritative for the management stuff. And then we just have to pass in a cloud config for the workload cluster. And I imagine this will all kind of start to work at least.
Yes, exactly. Because at the end, once you get the booster cluster, it is really apply some YAML, watch object, do something else, wait, do something else, wait.
Yeah, totally. No, this is like super helpful for me, Fabrizio. I kind of assumed it worked the way that you've described it here, but I didn't know for sure. So like seeing you walk through the code definitely is helpful for me, and it's similar in some respects to the OpenShift testing we do as well. So this is like it definitely makes sense to me, and I guess like now I just need to read more code, I think.
Yeah, but what I want to do is that I want to go into this autoscaler, see how, because I assume that if I want to deploy these on the workload cluster, probably some of these goes in the workload cluster and some of these goes in the management.
Yeah, absolutely.
So I have to basically create the service account on both sides. On the service management, I have to give him some roles. And on the workload side, I have to give him other roles, which are well defined in the template. So it should not be much difficult. And yeah, so probably you have to split this into 5, apply one on one side and one on the other.
Right. Yeah.
And
I think like as you're looking at this, it probably, and I'm guessing you're already thinking about this, but like it probably makes sense as we think about what the framework would look like for the autoscaler pieces. To kind of treat these as independent pieces that can be mixed and matched, So like if I want to run the autoscaler in a joined cluster, I could give it the RBAC for management and workload at the same time. If I want to run the autoscaler on the management cluster, I can give it the two different sets of RBACs for the workload and the management. Or if I want to reverse it and run it on the workload cluster and then, run, I could swap the way the pieces are going in. And there's even another style of running where it's like the autoscaler is not running on the management or the workload cluster, which is kind of odd, but like everyone loves to do things in kind of a different way. So yeah, I think if we make those pieces real modular, it'd probably make it easy,
we can make and yeah, we can make it easy. We can support different scenario. Let's start with one, which is, and that's it. Really, it is the power is. I think that what are the two main advantages? One is that you basically build on the shoulder of Cluster API and provider testing, because now it is used by almost all providers. And you get this thing that can run in the same way on your machine or on Prau. On Prau, it gives you all the logging. On your machine, you can use by make and get all the logs equal to Prau. Or you can attach to the debugger and basically debug everything, and so figure it out problem or develop in a nice way.
Yeah, no, I mean, this absolutely, we want to go this way for the tests. Like, I think the scripts that we put together for the first pass at doing our end-to-end tests, we just wanted to see if we could get it working and everything.
Yeah.
And I don't think
it was a first version, so it was perfectly fine.
Yeah, we didn't know the end-to-end framework in CAPI as much, as well as you do, certainly. So like seeing you kind of put this together, I think it's awesome. Like I'm totally in favor of it. Now I understand it a little better. I think once we get it working, yeah, I can't wait to see it integrated, and we can improve our testing there though. So like, yeah, I'm totally stoked. I think this is cool.
Yeah, just to show how it works, let's run the other test. So instead of because this one we were still debugging. Okay.
While we're here, I had a question for you though. The artifact, the underscore artifacts directory that's created, and I realize that if anyone's watching this, it might be tough to see, but is that the same artifacts directory or the output that gets created in Prau? So like if I'm running this locally, okay.
It is exactly the same.
Okay, cool. So like if I need to save if I want to save extra objects, this is a great way for me to test it locally to make sure it works before I put it into Prau or something like that.
Yeah, one of the principles when we developed this is that we want to run it locally like we run in Prau. Because when you have a problem in Prau, sometimes it's hard to figure it out. And so you just grab the same configuration, run it locally, you get the same output, and plus you get the debugging.
Right, and you're not like spending cloud resources while you're trying to debug getting the artifacts right and everything. Yeah, it makes total sense to me.
Exactly. But okay, let's stop this one.
Yeah, and I just want to know, we've been going for like an hour, so like if like I'm cool to watch some more testing and whatnot, but I just want to be sensitive to your time here because if
I will just show you a test that runs locally. So
cool.
Instead of us doing autoscaler, we do quick start, which works. Quick start without this, probably. Okay, we apply the configuration just for, let's clean up this. Probably I have something pending because I stopped the test in a bad way. Because end-to-end tests also have a run cleanup procedure at the end, which is nice.
Right. You're just killing everything. I just like wipe out all the containers. Like,
okay. Okay. I have only my management cluster running. So I run the quick start. Let me just check. Okay, quick start. I should have tried it. So I do not debug, but just to show. So when you run, and this is more or less the same or doing make run. This is the output that you get even in your artifact folder. When you go in test grid, this is the first things that you see. Let me do reload. Artifacts is being created. This is the repository that is using. It is provisioning the cluster, so you can. Here it is, load balancer coming up, control plane coming up. If you want, this is Docker, so you can even do Docker exec. You go into Docker, you do export kubeconfig Kubernetes admin.conf, and then you can do yeah, get ports -a. So here we have you can see kindnet running. So our test is proceeding. And Whitefield, no, it is still proceeding. It applied the cluster, it got at the end, it waited for the cluster infrastructure to be provisioned. So it did all the check, passed. When it got at the end, it dumps everything. So if we go here on the cluster, this is the namespace that was created for our test. Basically, namespace is the name of the spec plus a random thing. And you can see the bump of the object. So you can see logs from the machines, in this case from the kind cluster, so journal, kubectl, container-d logs. And then you can see, these are the bumps from the, oh, that's a nice one. These are the bumps from the Kubemark provider. It is trying to get logs from Kubemark provider. And here you can have, we are bumping everything from that namespace, the cluster object. The cluster object, you can look at your Kubemark machines. We are even bumping metrics even if we don't have things relevant. So it gives you, and this basically you get it for free every time someone improve it in copy, you get it for free, and more or less.
Yeah, totally. I think this is awesome, and like a good instruction as well. I guess just as a bookkeeping note, if anyone is watching this on YouTube, I will put links in the description for the pull request we're talking about and some of the things that Fabrizio and I went over. But Fabrizio, thanks a lot. This is like an awesome introduction for me, and it definitely helps me out.
Yeah, let's get the second test passing, and then we switch. It is Golang code. You want to create an external kind cluster, 10 lines of code, and you got it. And so.
Yeah, no, absolutely. I think just standardizing on the EDE test style that we're using in Cluster API and with the other providers, getting it into Ginkgo. Yeah, like I'm all for this. I think it's a great progress forward, and to kind of, I think once we get this in place and we kind of get the testing set up the way we want to and automated, we should probably think about releasing like a 1.0 Kubemark provider at that point, and we can start to think about going into, I guess, ready mode or something, or
Yeah,
beta.
maybe sometime during March or April will be,
Right. Yeah.
considering that we are doing this, let me say, as a background task. But yeah, we're making good progress.
Right. Yeah. Like I'm thinking, if by summertime we had like a 1.0 release and we were confident that people could then use that for testing in other places, that would be ideal for me. That would be like the mark that we're ready to go.
Yeah, my goal is that sometime before or after the next copy release to have a copy autoscaler test in Cluster API using Kubemark. And if we get there, we have to make it work with cluster class. There are still some things to do, but that will be already a good result. And then we can figure it out.
Yeah, totally agree. Totally agree. I look forward to seeing what happens.
Okay. Thank you, Mike. Have a nice weekend.
Yeah,
Bye-bye.
thanks, Fabrizio. Have a good one. Later.